For each of the following balanced half reactions, determine whether an oxidation or reduction is occurring. Remember that oxidation is loss, reduction is gain. Now, when oxidation is loss, what that means is electrons are on the product side because the reactant has lost electrons. Reduction is gain means electrons are on the reactant side. The reactant has gained electrons. So knowing that, this is reduction and this is oxidation. This one is also oxidation and this one is reduction. Number 2, for each of the following unbalanced half reactions, determine whether an oxidation or reduction is occurring. Well, first let's balance. We put a 2 in front of the chlorine. Then we must need, and remember, all elements in their elemental state have an oxidation state of 0. So we must need 2 electrons over here to make this make sense. This is an oxidation reaction. Here we have manganese, 2+ on the reactant side, and on the product side we aren't sure what it is. So let's analyze and then we'll balance. Oxygen, when it's bound to something, has an oxidation state of -2. It's defined that way. Now we have 2 oxygens, which means we have a -4 being contributed to this molecule from the oxygen, which means our manganese must be a +4. Now if we're going to balance this half reaction, remember we balance our oxygen by adding water, and we need 2 of them. Then we would need 4 hydrogens on this side. And now we need to balance our charges. We have a +2 over here. We have a +4 over here, which means we would need 2 electrons to be added here. This is also oxidation. Remember, oxidation is loss. So we're losing electrons to the product side. Our electrons are on the product side. In C, hydrogen gas, H2, is in its elemental form. It's defined as having an oxidation state of 0. We have 2 hydrogens on the product side. We must have 2 electrons that were also released from our diatomic hydrogen. So we have another oxidation. Now the NO3- reacting to form NO is going to be a little bit more involved. First, let's look at our oxidation states. Remember, oxygen, when it's bound, has an oxidation state of -2. We have 3 of them here, so oxidation brings a -6. So we must have a nitrogen of 5+ in order to make the anion overall charge -1. Here, the nitrogen must be a +2. So let's balance this half reaction. It's good practice. So in order to balance our oxygens, remember we add water. I need 2 waters so that I have 3 oxygen atoms on each side. Now to balance my hydrogens, I'm going to add hydrogen ions. Now I need to analyze my charges. I have a +4 and a -1, which means I must have, which overall would be a +3. I have a no charge on this side, so I must have 3 electrons on the reactant side. Because it's on the reactant side, that is a reduction. Number 3, given the following pairs of balanced half reactions, determine the balanced reaction for each pair as in an acidic solution. So for A, I have my calcium being oxidized, and I have my fluorine being reduced. I don't have any oxygens or hydrogens to contend with. Everything is balanced. We use the same amount of electrons here, so I can just go through and add up my oxidation and reduction reactions for my overall reaction. For B, again, we have no oxygens or hydrogens to contend with, but this time we have a mismatch in our electrons. So we're going to have to multiply one of our equations in order to get our electrons to balance. Because remember, with a redox reaction, we need the same number of electrons in the reactant and in the product. So here, we need to multiply our lithium, our oxidation reaction, by 2. And that will increase our electrons so that they match. So I would have 2 lithium plus whatever I have in my chlorine. I'm going to put the electrons in this time. 2 lithium, 2 electrons, and then my chlorine. Then I can remove the electrons, and I have my overall reaction would look like this. For C, again, we don't have any hydrogens or oxygens to contend with, but we do need to make sure our electrons match. This time, we can't just multiply one of our reactions, we have to multiply them both. And then you need to find the least common factor. So I would multiply my iron by 2, and I would multiply my bromine by 3. And that would give me a total of 6 electrons for the reaction. So now I can eliminate the same on both sides. And then I have my balance. And for D, we have our silver being oxidized. And then we have a permanganate down here. Now we're told they're balanced. So I just need to be comparing my electrons in this case. And the silver would need to be multiplied by 3 in order to have 3 electrons on both the reactant and the product side. So this would be our overall reaction.